Alright, so for part 2, let's take a look at Han and Leia. Alright, so Han and Leia start walking at the same time from the same point and in the same direction. Leia starts with a 12-inch step and increases her stride by half an inch each step. She goes 21 steps and then stops. Han starts with a 36-inch step and each subsequent step is 90% as long as the preceding one. So his are getting smaller while her steps are getting longer. So the first question says, what type of sequence is Leia's steps? So let's look at the pattern. She starts with 12. She's increasing it by a half an inch each time. So if you notice, we're adding 1/2 an inch each time. So that's our common difference. So Leia's is arithmetic. Whereas Han's, he starts with 36 inches, and we're going to multiply by 0.9, or 90%. And, of course, if you take out your calculator, take 36 times 0.9, we get 32.4. Multiply that by 0.9. Second answer times 0.9, we get 29.16. So, since we're multiplying by 0.9, that's our common ratio, and therefore Han's is geometric. Now, the next question is, how long was Leia's step? Well, this is a sub n. We're looking for the 21st term. So, get a sub n. Remember, that's our first term, which is 12, plus the common difference, which is 1/2, and then it's n minus 1. So, to get the 21st step, we get 12 plus 1/2 times 20. And I'm just going to type that in my calculator, although it's not too hard. We could probably do that in our head. 12 plus 0.5 times 20. And we get 22 inches. So her last step is 22 inches. Now, after 21 steps, who is ahead? So now we're looking for a total distance. We're looking for the total distance, which means we have to use our sum formulas. So for Leia, remember for Leia, it's arithmetic. That's easy. Her total distance is the first term, which was 12 inches, plus the last term, which is 22 inches, times that by the number of terms, 21 steps, divided by 2. And we just do our calculator. I'm going to go 12 plus 22, multiply that by 21, and then divide that by 2, and we get 357 inches. That's the total distance Leia walked. Now, for Han's was geometric. But be careful, for geometric we had two formulas. In this case, it is a partial sum. And the formula for that, S equals the first term times 1 minus r to the n over 1 minus r. So his first step, Han's first step, remember, was 36 inches. Times 1 minus his rate, 0.9 to the 21st over 1 minus 0.9. And I'm going to type this in the calculator very slowly. Do the 1 minus 0.9 to the 21st. Divide that in parentheses, 1 minus 0.9. And I'm going to multiply that by 36. So Han had traveled 320 inches in 21 steps. So almost caught up with her. And that's what the next question is. If Han keeps walking in the same manner, will he ever catch up to where Leia stopped? This is an infinite sum. This is an infinite series, because if he just keeps walking, and that's the hint right there, if he just keeps walking, that's a sign it's an infinite series. So remember, our formula is a sub 1 over 1 minus r. Well, his first step is 36. 1 minus the 0.9, and I just typed this in my calculator. 36 divided by 1 minus 0.9. Oop, quit. 36 divided by, you got to put the bottom in parentheses. Don't forget that. I almost forgot that. 1 minus 0.9. Hit enter, and he gets 360 inches. So therefore, the answer, of course, is yes. He will catch up with it if he walks forever and ever and ever and ever and ever and ever. Because if he were to walk forever, keep At the same rate, he will walk a total of 360 inches. All right. The next question. All right. Luke bought 2 Ewoks from Chewbacca. Little did Luke realize that Ewoks reproduce fast. After 1 week, there were 4 Ewoks. And at 2 weeks, there were 8 Ewoks. So he starts off with how many Ewoks? So the question is, how many Ewoks will there be after week 4? Now, this is really kind of tricky when it's like the problem like on the front page, where we had to make 77 deposits, not 76. And for this problem right here is going to be 5. And the reason for that is he starts with 2 Ewoks. After the first week, he has 4 Ewoks. After the end of the second week, after week 2, that's where he has 8. So if I'm looking for the third week, we get, 16. And the fourth week, we get 32. Now for something like this, 5, I would just keep with the pattern. But I like doing this because we can see why n is 5. There are 1, 2, 3, 4, 5 terms for this one. And that becomes important for part D. Well, okay. Now, this is a slightly harder question right here. You will need a calculator. Luke decides to cull the Ewoks if their population becomes greater than 1,000. After how many weeks will he need to cull the herd of Ewoks? Alright, so to answer this question right here, what we're going to need to do is talk about the sum. Now, this will be a partial sum because he wants the population to stop eventually. So we're going to look at our partial sum problem. It says this: to get the sum, it's the first term times 1 minus r to the n over 1 minus r. So we know that the population we want to be 1,000. We know the initial population is 2. We even know r. The only thing we're looking for is n. We need to find n, the number of days, or weeks in this case. We get 1 minus r, we know is 2, because it's a common ratio. 2 to the n over 1 minus 2. The rest is just a little bit of algebra. Divide by the 2, we get 500 equals 1 minus 2 to the n over negative 1. Cross multiply, we get negative 500 equals 1 minus 2 to the n. And to solve it, 501 equals 2 to the n. I subtracted the 1, I just canceled out the negatives. Now we have to take the natural log. Natural log of 501 equals the natural log of 2 to the n. So what does n equal? And you can do this. Remember the whole rule. The whole reason we use the natural log is to bring down the power. We get n natural log of 2. So therefore, n equals the natural log of 501 divided by the natural log of 2. Exponents. They're everywhere, baby. So I typed it in there as you can see. The natural log of 501, divide that by the natural log of 2, and we get this, 8.97. But we're going to round, and we're going to round up here because we're talking about the number of days here, or weeks. So about 9 weeks he'll have to cull the herd. Okay? All right, so take a look at these and redo part 1 and part 2 if you need to, and we'll see you in class.